Hello, how are you? Hope you're in good health. So, let's start with today's lecture. So, today we are going to talk about the numbers written in the standard form. So, just to tell you how standard form looks like you may have seen numbers like this 3 into 10 raising power 8, or you may have written like something 2.4 into 10 raising power minus 11. So these numbers are basically the examples of standard form. So let's start with the lecture. Um, we discussed about how we can solve the solutions for number written in the square form, like square of 10 would be like here is the square of 10. Here you can write it like this. So this would be equal to 10 cross 10, that would be equal to 100. So we can write 100 in this form, So the standard form of writing 100 would be like this. So for example, there is a figure 1000 and you want to write it in the standard form. So what you will do is count the zeros. So there are 3 zeros in it. So just we can write it like this: 10 raised to the power of 3. So count the number of zeros and write it over here. So this would be the standard form of writing 1000. To solve 10 raised to the power 3, we can do like this as we did here. So that equal to 10 cross 10, 10 multiplied by 10 multiplied by 10. So that would be equal to 1000. So hence proven. We started with the figure 1000. We wrote it in the standard form and then solved it and got the same answer again. Let's look at some other big numbers. How we can write it in the standard form, this number. So we'll have to count the zeros again. So there is 1, 2, 3, 4, 5, 6 zeros. So we can write this number like this: 10 raised to the power 6. So this would be the standard form of this number, standard form. A question may arise like to write kilo and mega in standard form. So as we know that the kilo is equal to 1000, so kilo is equal to 1000 like this. So that would be equal to 10 raised to the power 3. This would be the standard form for kilo, and this would be the standard form for mega, because mega is equal to 10 raised to the power 6, or mega is equal to 1 million units of anything. So that is equal to 10 raised to the power 6. This is mega. So one more example, how to write this number in standard form. So again, we will count the zeros: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So we are going to write 14 over here. So this is how we can write the numbers in standard form. Okay, so you may have also seen the numbers like this: 10 raising power minus 3 or 10 raising power minus 4. So what does the value minus means here? So let's talk about this. For example, there is a number 0.1. So 0.1 is equal to, it is either equal to 1 divided by 10. So if we divide 1 by 10, we will get the same answer, that is equal to 0.1. Or in other words, we can write it as 10 raising power minus 1. 0.1 would be equal to 10 raising power minus 1. Okay, let's solve another question. What would be 0.01 equal to? This would be equal to 1 divided by 100, because 0.01 is the 100th part of 1, so that would be equal to 1 divided by 100. And we can write 100 in this form, like 100 we can count the 2's. There are 2 number of zeros, so 100 would be equal to square of 10. So when this value goes in the numerator, it can be written as the negative positive sign of this power would be changed to a negative sign. So this would be equal to 10 raising power minus 2. So there is another way to solve it. That is, you have written 0.01 here, and that would be equal to 1 multiplied. You can write this 1 multiplied by, or even you can skip this, because we are going to write something here in the later examples. So for 1 you can skip the number 1, there is no need to write 1, but in a standard form you can even write it. So if you want to shift 1 to this position, this 1 to this position, we have to like shift it 2 places decimals and to the right. So we can write it as 10 raising power, simply write it as 10 raising power minus 2. Let me solve another example. For example, this is 0.001, so that would be equal to, if you want to shift the 1 over here, or if you want to write it in the standard form, what you can do is count the number of jumps one would have to make to shift to be shifted to this position. So this will be 1, 2, 3, 4. We have to like take 1 to the other side of the decimal. This is the decimal, so we have to make 4 jumps. So this number would be equal to 10 raising power minus 4. So let's do another example for this method. We have to write this in standard form now. So just to simplify, we are going to count the number of, like here, as we count the number of zeros. So here now we have to like count the number of jumps, or still the number of figures that the one has to shift to get on the other side of the decimal. So this will be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So in this case, it would be 10 raising power minus 11. So let's do some other questions. So now we are going to do some addition and division for the simpler standard form questions. For example, and multiplied by, so here are some questions for examples. 10 raising power 4, 10 raising power minus 5, 10 raising power 6, 10 raising power minus 3, 10 raising power minus 4, 10 raising power minus 2. So here are 4 questions that we are going to solve for improving skills regarding multiplication and division of the standard forms. So all of the multiplication questions, we will just simply add the powers. For example, like here is a question: 10 raising power 2 multiplied by 10 raising power 2. So we are going to add the two powers, like 2 plus 2 would be equal to 4. So it would be equal to 10 raising power 4. We can also prove this by square of 10 is 100, and again square of 10 is 100. So this will be equal to 100 multiplied by 100. So that would be equal to 10,000. In this case also, we can use the same technique, and we can like multiply 10 4 times, so that would be equal to 10,000 also. So now we have like a proof that by simply adding the powers we can get the answer. In both case, it is proven. So let's get back to this. So the answer for this would be 10 raising power 2 plus 3. So the powers would be added, the base would remain same, so that is equal to 10. So the answer would be 10 raising power 5. So in this case, again we are going to use the same technique. The base would remain same, that is 10. So we are going to add the powers, so that would be equal to 6. So there is a negative sign with it, so that would be equal to 6 minus 3. And now that would be equal to 6 minus 3 is equal to 3. This would be equal to 10 raising power 3. In this case, it would be equal to 10 raising power 4, and there is a negative sign with it, so we are going to subtract 5 from 4. So 4 minus 5 is equal to minus 1. So this would be equal to 10 raising power minus 1. The last one, 10 raising power minus 4 and minus 2. So what we are going to do is we are going to add these two. So there's a negative sign with 4, negative sign with 2. So we're simply going to subtract them. So this would be equal to, if I draw the number line like this, so this would be equal to, suppose there is a 0 here, 1 2 3 4 5 6. So there is a 0 here, and this is minus 2, this is -4, this is -6, -1, -2, -3, -4, -5, -6. So we're going to start from -4 and we have to like subtract 2 more from it. So let's jump 2 steps to the right, so that would be equal to -6. So -4 minus 2 would be equal to -6. So the answer would be 10 to the power -6. So at the start of the lecture, I told you like a number in a standard form. You may have seen some numbers like this, and here is the standard form for any number. So for a number to be written in the standard form, it is must that the decimal should be after the first digit. There must be a decimal, or if it is a whole number, like it can be in this form. For example, it can be in this form: 4 into 10 raising power, anything like 4 into 10 raising power 7. But in this case also, there is a decimal here with 4.0, but as 4.0 is equal to 4, so even if we write it as 4, it is okay. So for a number to be written in the standard form, it is must that the decimal should be after the first digit, and there must be a like a quotient or power written at the end of the number, raising to the power of 10. For example, now we are going to talk like what the standard number really are. Before that, we were just talking about the exponents of 10, and now we are going to like add it with some number, because all of the numbers would not be the multiples of 10. So for example, the speed of light is equal to 3 into 10 raising power 8 meter per second. In other words, the speed of light is equal to 3 multiplied by 1, 2, 3, 4, 5, 6, 7, 8. It can be written in this form, and then finally in this form. Okay, so to simplify this number, we write it in the standard form like this. Let's do some other examples. It might get more clear to you. For example, there is a number 234, a number like this, and we want to write it in the standard form. So what we can do is, the first step would be to write it like this. Just add a decimal after the first digit and count the number of the digits after the decimal. Like here you have placed a decimal, so count the numbers of the digits after the decimal. So here are 7 digits, so you can write 7 here. So this number can be written in the standard form like this. Let's solve another example. Random number, any random number. So this can be written in the standard form like, just add a decimal after the first number, ignore all of the next numbers in the line, because you are going to write a simple number, not a complex number. So, and count the number of digits: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this number can be written like this in the standard form. The other examples are of the numbers with numbers in this shape. So again, the methodology would be same. We have to right, we have to place the decimal after the first number after the zero. So that would be equal to 3. The first number after the zeros is 3. So we are going to place the decimal here. Then we are going to count the number of places the decimal has jumped, like it jumped 1, 2, 3, and 4 times. Or you can say the number 3 jumped 4 times to get on the right side of the or on the left side of the decimal. So we are going to write 3 into 4, 10 raising power minus 4. Another example would be 0.21. So in this case, if you write it in the standard form, it can be written like this: 2.1. Now because the decimal shifted just one place, so we can write it 10 raising power minus 1. So if it was 21, it would have been 2.1 10 raising power 1. So let's solve another example. And suppose there is a number 0.04. So we can write it like this: 4 into 10 raising power, like the decimal I have to shift 2 places, it would be minus 2. On the other hand, if we write 400, so the decimal would be placed here, so it would be like 4 into 10 raising power 2. So this is the difference between negative power and the positive power. So this concludes how to write the numbers in the standard form. You can review this lecture because I have stated many examples. So you can and just one last thing. For example, there is a number like this. There is a number p that is equal to 3 into 10 raising power 2, and there is a number q that is equal to 4 into 10 raising power 3. There is a number p that is equal to 10 raising power 2, and this is equal to 4 into 10 raising power 3. So what to do if we want to multiply and divide p by q? So we are going to do this example in the next lecture. So that concludes